Okay, let's go ahead and do some problems from section 1.3. This one gives you the concentration in terms of the number of hours t since medication has been given. This is a quadratic equation because the variable is squared. We need to go to the quadratic sheet and put in our coefficients of -2, 3, and 27, and now we can answer any question. How long does it take until the drug totally leaves? Well, when the drug totally leaves, there will be no concentration. So the concentration will be 0. Put 0 in for y, and you get these two answers. And the only one that makes sense is 4.5. So in 4.5 hours, the concentration will be 0. B says, when will the drug's concentration be at a maximum? The max or min is automatically calculated right here, and that's in 0.75 of an hour. You will get the maximum concentration. What is the maximum concentration? That's the y value of 28.125. The reason it's the y value is because the c variable here is playing the role of the y variable on the Excel sheet. See, the equation is in this format: y equals, and that's c equals. T is playing the role of time. Okay, let's go on to 3. And this is the same type of problem. It gives you, here's your A, -1, here's your B is 12 in your quadratic sheet. The C is 0, then put 11 in for the Y. 5, same type of thing. Here is your A, this is the number in front of the variable squared, so -0.6 is your A, your B is 175, your C is 0. Then this is asking for the x part of the vertex point, this is the y part of the vertex point, and the physical significance of the p-intercept or x-intercept. Well, the x-intercept tell you what the y is when the x is 0. So what would the revenue be when the price is 0 is what it tells you. It actually turns out to be the 0.00. So in other words, actually you get two x-intercepts. One is at 0, a 0, which means if the price is 0, the revenue is 0, and I believe you get another one too, which is a rather large number. Let's go ahead and put those numbers in there. -0.6 right here, -0.6, and I think the B is 175. So this is 175, and then a 0, and then your x-intercepts right here, 0, 0, and 291.670, and again, you can get both of those by putting 0 in for y right there. And this means that if your price is either one of these amounts, $0 or 291.67, the revenue would be 0. And what prices will result in no revenue? And we just got that right here. That's the prices that will result in no revenue. So that's 6, and then 7, it gives you another equation. Here's your A, B, and C, and you can answer those questions. It's pretty straightforward. 9, it gives you data points, so you can get those data points by going to the data sheet. And if you go to the data sheet, here's problem 9, so you can copy that. Problem 9 is in section 1.3. Okay, problem 9, highlight it, copy, then go back to your quadratic sheet, and over here where you can put in your data points, let me click off that a second. Over here where you can put in your data points, just do a right mouse click and paste special as values, and you get these in. Click get equation from data points, and you'll get the equation. So that would be the equation, and now you can answer anything about it. Like for example, first of all, the coefficient determination is 0.93, which means that the model fits the data points well. It may not extrapolate, predict the future well, but it does fit the model well. And then you can get the year that it will be at its minimum, 75 years after 1950. What is the minimum? 3.502%. Down here, in what years were there 10%? So that's giving you a y value, so just put in 10 here since we used whole numbers for the percentages. So it would be in 23.157, and also at 126.991 years after 1950. The percentage of female teenagers that are married is 10%. Y-intercept, well, the y-intercept put 0 in for x, and you get 17.089. This means, according to the model, in 1950, 17.089% of teenage females were married. I know the actual was 16%, but this is the predicted amount based on the model. And the x-intercept put 0 in for y, and you get that there are these two non-real x-intercepts. So there's no real solution to that. It also says up here no x-intercept. So if there's no x-intercept, that means there will never be a time when the no female teenagers will be married. So that will never happen. And so those are those type of problems. And then on problem 12 and 13, it gives you an equation that is not in standard form here for us, ax squared plus bx plus c form. So you could either FOIL this stuff together, take x minus 100 times x minus 100, you get something like x squared minus 200x plus 10,000, then take the negative 0.05 through and add the 20,000. Or you can, there's a couple things you can do. You could use the right hand side of the sheet and put in your coefficients over here, since it's set up to handle equations that are in standard form. The form that I was talking about previously that we use over on this side is called the general form, and that's the one we usually see. But this one, standard form, here we don't see that as much. But you can put in your coefficients here if you wanted to. That'd be negative 0.01 minus 200 and well, actually I'm going to do the problem number 13. So that's negative 0.05. Sorry, negative 0.05 minus 100 and 20,000. And if I do that, what it does here, if you ever see this, it just means it's too wide. The number is too big, so just widen it out here and you can see it. This tells me the x-intercept, y-intercept, all that sort of stuff. And here is the maximum. It occurs when the x value is 100. The number of units sold is 100, and here will be the maximum revenue of $20,000. So notice these are the answers, but we could also get this on this poly sheet, the next sheet, poly sheet. Put in your coefficients in negative 0.05, 1. See, we have 1 in front of the x there, 1 in front of the x. The b is 1, c is minus 100, and the d is 20,000. It simplifies it. Click this and it copies it over to this area, and look, you get the same exact answers as we had over here on the right hand side of the sheet. So oh, sorry, that is the right hand side of the sheet. Okay, let's go over here to the left hand side of the sheet, and we get this, see, negative 536 and 732, and that's the same answers we had with the same min and max that we had on the previous problem right there. And we'll do one more problem in just a second. On this problem, a rancher has 300 feet of fencing with which to enclose 3 adjacent rectangular corrals. What dimensions will produce the maximum enclosed area? Well, we'll call each of these horizontal lines x. So we have 2 x's, this one on the top and this one on the bottom, and we have 1, 2, 3, 4 y values going up and down. So 2x plus 4y has to give me the total amount of fence I have, which is 300 feet of fence. Solve this for y, so I subtract the 2x from both sides, then I divide by 4, and I get this equation. Now substitute this into the area equation. Area equals length times width, or x times y, and I get area equals x times y, and this is y right here, so I substitute that in for y, and then just distribute through the parentheses, and I get this quadratic equation. Now you can put in these coefficients into your Excel sheet. Negative 0.5 for the A and 75 for the B. There's 0 for the C, and then your maximum area is the y value, because here A is acting as the y value. So the maximum area is 2,812.5 square feet if the x distance, the horizontal distance, is 75. And so now to get what the width should be, just take the area divided by the length and you'll get the width. And right here I did that. I just take the 2812.5 divided by 75 and I get 37.5. So the dimensions of the rectangle to maximize the area is 37.5 by 75. And here on problem 22, It says the owner of a piece of land in Florida would like to go into the orange business. He has been told that if he plants 20 trees on his land, he will get 40 oranges per tree. He is also told that for each additional tree he plants, the tree will produce 5 fewer oranges. And so we're supposed to get the equation and see how many trees he should plant to maximize the number of oranges. So the number of trees he plants is 20 plus X, every additional tree. So X stands for the number of additional trees he plants beyond 20. Now over here, 400 is how many oranges he'll get per tree if he plants 20. But since he'll get 5 fewer apples per tree for each additional tree he plants, then that would be minus 5x. So the total equals the number of trees times the number of oranges per tree. So we need to multiply these two together. Now to multiply those two together, we could go to the poly sheet and put in our coefficients here on the left hand side right here, and put in those coefficients. The a on this first binomial would be 1, the b is 20, and on the second one the a is -5 and the b is 400. And when you put those in there, it'll FOIL it together for you right here, and then you can copy it over to the quadratic sheet, and you automatically have your answer right here. The maximum number of oranges that he can get is 12,500. That's if he plants 30 additional trees, 30 trees beyond the 20, so it would be 50 trees total. How many oranges per tree would he get? Well, take this number right here, so I'll do this here. Take the 12,500 divided by the total number of trees. Well, 30 is not the total number of trees, it's 30 plus 20, or 50 trees, and the number of oranges per tree he would get is 250. So it's a lot lower oranges per tree, but he's getting a lot more oranges total because he has a lot more trees. So that will do it on that section.